All right, here's lesson 8, rotations. So rotation is the transformation in which a figure is turned or rotated about a specific point. To rotate an object and find its image, you need to know the amount. So basically, if we have a little grid here, we're starting in this spot and we rotate here, that's going to be 90 degrees, 180 degrees, 270 degrees, and if you complete your rotation, that's 360. And there's two directions. There is clockwise, which follows the pattern of a clock, or counterclockwise, which goes the opposite direction of a clock. So let's try an example here. We have this triangle with vertices 0, 0, which is right on the origin, 3, 0, and 3, 4. And we're going to rotate it 90 degrees counterclockwise. So that's going to be moving from quadrant 1 to quadrant 2. All right, so if we look at the bottom of the triangle here, it starts at the origin and it moves 1, 2, 3 units across. So if we rotate this object, we're moving it this direction, the bottom of the triangle is going to be there. And from that point it goes up 1, 2, 3, 4. So we're going to do the same thing here, 1, 2, 3, 4. And then connect the lines to make the new shape. So we rotated that 90 degrees. And if we were going to rotate it, so it's a 90 degrees rotation. If we're going to rotate it 180 degrees, we would end up with something like 1, 2, 3, and 1, 2, 3, 4 up, and then connect it. So that's 180. And if we wanted to do 270, 1, 2, 3, 1, 2, 3, 4, that's 270 degrees. Okay. Sorry, and this is quadrant 3, and this is quadrant 4. So when a figure is rotated, the lengths of its sides are unchanged, the measures of its angles are unchanged, the orientation of the figure is unchanged, and the rotation image is congruent. That means the same as the original figure. And it's the same distance. We're going to work off this premise that it's the same distance from the center of rotation. So let's try another example here. RST has vertices R, which is negative 5, 0. So 1, 2, 3, 4, 3, 4, 5. Okay, that's R. S is negative 1, 0. And T is negative 2, 3, negative 3. So we end up with this image. So R, S, and T. All right. So we're going to do a 180 degree clockwise rotation about the origin. So the origin is that center point. So 90 degrees would put this image there, and 180 degrees puts it back into this quadrant. So let's focus on point S. So point S is 1 unit away from the origin. So S prime is going to be there. And R is on the same axis. So R is 1, 2, 3, 4 units, 5 units away from the origin. So 1, 2, 3, 4, 5. There's R prime. And the last thing we need to figure out is where's T prime? Well, T in the original is in quadrant 3. So a 90 degree rotation would put point T into quadrant 2, and 180 degrees puts it in quadrant 3. And if we follow basically this idea that T is going to be 1 that way and 3 up that way from S, we can do the same thing, 1 and 3, and there's point T. Okay, and there is our new shape. Call that T prime. Here we go. Let's do another one. So we've got point A, which is 3, 7. Point B, which is 9, 4. And point C, which is 6 and 9. So we've got this original shape. okay? And we're going to rotate it around point M, which is -4 and +3. So that is the center of our, that's where we're rotating, okay? So what I'm going to do is just draw a new sort of grid line. All right, so if that's like our center of rotation, it's kind of like our new point of origin, almost. Now, every point is going to be equidistant from that point. So let's figure out how far we need to go here. So from this point, we, I should label these. So that's A, and point B was 9, 4, and point C was 6, 9. Okay, so point A, if we figure out point A, it's going to be, we also need to figure out where we're rotating it. So we're rotating it clockwise 90 degrees. So if this is quadrant 1, we'll call that 2, quadrant 3, and quadrant 4. So clockwise 90 degrees puts it into this quadrant. So that's our first thing we need to do. Now the next thing we need to do is figure out how far away from this rotation point are each of the points. So A is going to be 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4 up. So our new point is going to be 1, 2, 3, 4, 5, 6, 7, and what did I say, 4 up? 1, 2, 3, 4. So right there is going to be our new point. We'll call that A prime. Okay, B prime is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 1 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 1 up. Puts it at -10 there. And that's B prime. And C prime, our last one, is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over, and 1, 2, 3, 4, 5, 6 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6. So -7, 2, -7. And that's C prime. So that's a 90-degree clockwise rotation of that image. So the next one, let's draw this quadrilateral with vertices A, 3, -1. So there's A. B is -2, -2, 2. Oh yeah, there we go. There's B. And, oops, I got point A wrong, on the wrong side. Point A is 3, 1. There we go. And -2, 2. C is 1, -1. And D is 3, 3. So 1, 2, 3, 1, 2, 3. There we go. That's D, C, A, and B. All right, and we are rotating it around point D. So we're rotating it around point D, so that's like our new origin point. Okay, so I'm just going to draw a new sort of axis lines for that. So the nice thing about rotating around a point is the new point D is actually going to be the same as the old point D. We need to figure out where we're going with this. So we're going 270 degrees clockwise. So 90 degrees puts it there into quadrant 2. 180 puts it into quadrant 1. And 270 is going to put it into this third quadrant, the bottom right quadrant. So we said point D actually ends up being the same for the new shape. So D prime is there. We need to figure out how far from point D are the other points. So let's do some counting. So from point D, we're going to go 1, 2, 3, 4, 5, and up 1. So the new shape is going to be 1, 2, 3, 4, 5, and up 1. So that's B prime. And then A prime is going to be, just one more down and across. And then we need to figure out C prime. So C prime from the rotating point is 1, 2, and then 1, 2, 3, 4. So we do the same thing, 1, 2, 1, 2, 3, 4, and that's where our new point will be. We can connect that up, and that's going to be C prime, and that's called A prime. That's D prime. So we've successfully rotated this image 270 degrees clockwise around the point. Here's a PAT question that says the 2D shape on the Cartesian plane is reflected about the y-axis. So it's reflected on the y-axis. So if you think back to reflections, it's going to be the same. So we're kind of doing this thing going on. That goes like that, and that goes like that. And then we get, something like that. All right. If the original 2D shape and the reflected image combine to form a new 2D shape, what is the angle of rotational symmetry of the new 2D shape? Okay. So the angle of rotational symmetry, how many times did we have to rotate it for it to be symmetrical? We had to rotate it twice, okay? Because to rotate it once around a point, would put this original image into more of a horizontal orientation, okay? And then if we rotate it once more, it puts it back into that rotation. I know that's kind of confusing, but basically, we have to rotate it once and then again to actually match up the two sides. So the angle of rotational symmetry is 180. We have to rotate it twice. We're going to save this question for the next day, okay? And then we get into classwork on rotations. So again, first, figure out where your point of rotation is, and every point is just going to be the same distance away from that point. Keep in mind you're rotating it a certain amount of degrees. Okay. So try your best, and let me know if you need help.